Welcome students. Let us study factors affecting coupling constants. We know that the magnetic interaction between non-equivalent protons is known as coupling. It is also known as spin-spin coupling, and due to coupling of protons, splitting of the signal takes place. In this video, we are going to see which factors affect on geminal and vicinal coupling. Let us study that. First we see factors affecting geminal coupling constant. The geminal coupling constant is the coupling between two non-equivalent protons present on same carbon atom, or these protons are separated by two bonds. That coupling is known as geminal coupling. The general range for geminal coupling is -20 to +44 Hz. 2J means it is a geminal coupling, protons are separated by two bonds. The first factor is hybridization of carbon atom. As percentage of S character increases, the bond angle increases, and there is a positive effect on geminal coupling constant. In case of methane, the carbon atom is in sp3 hybridization state, and the coupling between these two protons, although we see that these protons are equivalent, but coupling between or magnetic interaction between these two protons, the coupling is -12.4 Hz. In case of ethylene, the carbon atom is in sp2 hybridization state, and the coupling is +2.5 Hz. The second factor is effect of substituents. The electronegative atom substitution in alpha position on sp2 and sp3 methylene groups leads to the positive change in geminal coupling constant. In case of methane, the coupling constant is -12.4. In case of chloromethane, it is -10.8. There is a positive change. In case of dichloromethane, -7.5. In case of that carbon atom is in sp2 hybridization state, there is a electronegative atom at alpha position, and there is a positive change +16.5. If there is oxygen, the coupling constant is +42.2. That is, there is a positive change in coupling constant. The electronegative beta substitution leads to negative change in geminal coupling constant. In case of ethylene, it is +2.5, but if there is a electronegative substitution at beta position, this is alpha carbon atom, this is beta carbon atom, and if there is a electronegative atom at beta position, there is a negative change -3.2. If there is a methoxy group, there is a negative change -2.0, and in case of chloroethylene, it is -1.4. That is the effect of substituent on geminal coupling constant. Then we see factors affecting vicinal coupling constant. Vicinal coupling constant means the coupling between two non-equivalent protons present on adjacent carbon atoms or separated by three bonds. It is also known as vicinal coupling. 3J means these protons are separated by three bonds. The first important factor is dihedral angle between vicinal CH bonds. 3J coupling constant depends upon the dihedral angle between two CH bonds. In this case, this is the front carbon atom and this is the rear carbon atom, and the dihedral angle between two CH bonds, that dihedral angle determines the value of vicinal coupling constant. And the relationship between dihedral angle and vicinal coupling constant is given by Karplus equation. 3JHH is equal to 8.5 cos square phi minus 0.28. That is the Karplus equation. And according to that equation, we study the Karplus curve. This is the Karplus curve. This is the dihedral angle from 0 to 180 degree. And that is the coupling constant values. And we know that according to dihedral angle, there are different conformers are possible, and If the dihedral angle is 0, the conformation is eclipsed. If dihedral angle is 180 degree, then conformation is trans. And if the dihedral angle is in between that eclipsed and trans, there are different conformers are possible. Out of that conformer is gauge conformer, which is obtained at 90 degree. And the variation of vicinal coupling constant with dihedral angle is represented by this curve. That curve is known as Karplus curve. By this curve, we see that the value of vicinal coupling constant is maximum, that is about 10 Hertz, when the dihedral angle is 180 degree, that is it is a trans conformation or staggered conformation. Or it is also nearer to 10 when the dihedral angle is 0 degree or eclipse conformation. That is, at dihedral angle 0 and 180, the value of vicinal coupling constant is larger. While the vicinal coupling constant is minimum, that is nearly 0, when there is a dihedral angle 90 degree, that is a gauge conformation. And that area indicates the variation of vicinal coupling constant with dihedral angle. For example, cyclohexane. In case of cyclohexane, there are two types of protons, axial and equatorial. Axial and equatorial. And the vicinal coupling constant between axial and axial, it is 10 to 13 Hertz, because conformation is trans or staggered conformation. Or the coupling between axial and equatorial, or equatorial and equatorial, it is less, it is 2 to 5 Hertz. That is, vicinal coupling constant depends upon the dihedral angle between two CH bonds. The next factor is cis and trans isomerism. In olefinic system, coupling of trans protons is always greater than cis protons. J of trans is 10 to 15 Hertz, or J of cis is 2 to 3 Hertz. Sometimes in question paper we have to, there is a question, how will you differentiate or distinguish between cis and trans isomer? Then remember that in case of trans isomer, the coupling constant is larger, and in case of cis isomer, the coupling constant is less. Then another factor, vicinal coupling constant in case of aromatic system. In case of aromatic system, J of ortho, that ortho is of the type vicinal coupling, and it is a very large, it is 6 to 10 Hertz. And the coupling between A and M, that is meta coupling or para coupling, the value is very, very less. And this is not a vicinal coupling. Meta coupling and para coupling, it is a long range coupling. And as the number of intervening bond increases, coupling constant decreases. Only remember that in case of ortho coupling, this is a vicinal coupling. The value of vicinal coupling in aromatic system, it is a quite large, it is a 6 to 10 Hertz. Thanks for watching this video. Thank you very much.